everyone, it's Miss Haynes talking here, and I am one of the science teachers at Cardinal Newman. What I want to talk about today, or what I want us to go through today and think about, is how do we breathe? Now, I don't know if you've ever thought about how air moves into and out of your lungs. Often people think of their lungs almost working like a vacuum cleaner, pulling the air in, but this isn't the case at all. Firstly, we don't have a motor to pull the air in, and there would be nowhere for the air to go out the other side. To really understand it, we want to look at the structure of our thorax first and the structure of our breathing system first. Now, your breathing system looks something like this. I said we're looking at the structure of the thorax, and the thorax is everything between your neck at the top and your kind of tummy at the bottom here. All the things held in your ribs count as being part of your thorax. We'll know lots of the parts on this diagram already. We've got the nose and the mouth at the top, and this is where air comes in and goes out. Then there is this tube, the trachea, and really is just a tube, and it carries the air between your nose and your mouth and into your lungs. This here is your rib cage, and the rib cage is there to protect all the really vital organs in your thorax, like your heart and your lungs, but they are also really important in getting air in and out of your lungs. These are your lungs here. You've got two, one on each side. And the lungs are spongy and stretchy and rubbery, kind of like a balloon. They're not muscly at all. They don't have any muscle, which means they can't contract and squeeze to move air in and out. So they can't move air in and out on their own. And so at the bottom here, we've got the diaphragm. And the diaphragm is the star of the show when it comes to breathing. It's what's really responsible for moving air in and out of your lungs. The diaphragm is this really strong, stretchy sheet of muscle that sits in a dome at the bottom of your thorax, and it's what really moves air in and out of your lungs. I want us to learn a little bit about gas pressure if we're really going to understand how this all works. Don't worry if it stops making sense at any point. It's a pretty tricky idea which you'll learn about again in your science lessons next year. So you might know, or you might remember, that gas particles have a lot of energy and they move around all over the place. When they're moving about, sometimes they're going to bump into the side of the container that they're in. And when this happens, they exert a little bit of pressure. This is kind of like if you were running about and you bumped into someone, you could knock them over because you've exerted so much pressure on them. This is what happens on a really small scale when gases move around. If there's only a few gases in a container, they're only going to hit the container every now and again, and so overall they don't exert very much pressure at all. If there's loads of gas particles in a container, they'll bump against the container really often, and so overall they're going to exert a lot of pressure. Also, imagine those gas particles again. If they're in a really big container, they'll bump against the sides less because there is more space and it will take them longer to get to the sides, so they exert less pressure. They're bumping into it less often. But if you put those same particles in a really small container, they exert more pressure because they're bumping against the side of the container more often. And then I want us to imagine that there's an opening in the side of the small box. You've got lots and lots of gas pressure. When you open it, all the gas particles will rush out of the container to move away from their high pressure situation. And this happens every single time. Gases will always move from where there's really high pressure to where there's lower pressure. So they'll try and get away from their high pressure situation and move into where there's lower pressure. And you'll have seen this happen if you've ever opened a gas canister, which contain gases at high pressure. Or you'll know if you open the end of a balloon and all the air rushes out, it's because the gases are moving to where there's less pressure. The same thing happens with aerosol cans, which also contain gases at high pressure. bike tyres, and whenever I try and deflate an airbed, I always lay on top of it. And what that does is it makes the inside of the bed smaller. You're making that container smaller, meaning the gases are under higher pressure, so they rush out really quickly. This is all also exactly how lungs work. So this animation shows us our lungs in action. And what I should really say is it shows us our diaphragm in action, because that's the thing that makes the biggest difference. When you take a breath in, your diaphragm contracts, causing it to flatten and move down. And can you see that when it moves down, it makes your thorax bigger? Think back to those boxes. When you've got your gases in a bigger box, they're under low pressure. So the diaphragm flattens to reduce the pressure in your thorax. It reduces so much it's actually lower than all the gases in the air in our atmosphere, so it's lower than atmospheric pressure. And remember I said gases move from where it's high pressure to low pressure. Because we've got all that low pressure in our lungs, the gases get drawn in. Then, when you need to breathe out, your diaphragm relaxes and it domes back up, it moves back up into that dome shape. And this makes the thorax smaller. Again, think of our boxes. When the gases are in a smaller space, they're under higher pressure. So your diaphragm moves up, increasing the pressure, and all the air rushes out of your lungs, like the air rushing out of my airbed when I lie on top of it. So watching this animation, when the diaphragm goes down, we've got bigger thorax and air goes in because of the low pressure. Then the diaphragm moves up and all the air goes out because of the high pressure. We're going to make a model which will demonstrate how this works, and you're going to need a plastic bottle. Around about 1 litre will work really well. A thumb-sized piece of plasticine, or if you don't have plasticine, blue tack works as well. Some sellotape, an elastic band, a straw, a sharp pencil, 2 balloons and some scissors.
Hi everyone, I'm Miss Haynes. I'm one of the science teachers here at Cardinal Newman, and I'm going to show you how you can make model lungs using some stuff that you can probably find at home. So to do this, you're going to need some sellotape, you're going to need a bottle. I've chosen, it's I think just over a litre bottle, and you want to cut the bottom off it so that it looks like this. A straw, just a little lump of plasticine or blue tack would work as well, depending on what you've got lying around. And then you need 2 balloons, one just normal one, and then one I've cut the bottom off like this. Okay, what you're going to want to do is, firstly, this is going to act like our diaphragm. So you want to pop the diaphragm at the bottom of the bottle, which is our thorax. So I'm going to stretch this over here. It is hard, it might be a 2-man job, so get someone to help you if you need it. Oh, there we go. And then I'm going to sellotape that just to secure it, because it has a habit of pinging off. So use as much sellotape as you need just to secure that bit of balloon to your bottle. The sellotape's are also really useful to make a really good seal, because you don't want any air coming in or out here, so seal it up really well. And one more bit. Now we've got our diaphragm attached to the bottom of our thorax, like so. So you're going to have to get your balloon that you haven't cut up and your straw. And what you want to do is pop it in there and just use an elastic band to tie it quite securely around there. There's a bit of a knack to it, because you don't want there to be air moving in and out of it, but you don't want to tie it so tight that it blocks off the straw, because then it won't work either. So tie it around lots of times, but not so tight that you squash the straw down. A bit more. You can check that you've not done it too tightly by blowing in there. There's still air coming in and out of there, so that's fine, it can move in, no problem. Okay, take a piece of plasticine or blue tack, whatever you've got, and just use a pencil to put a hole through the middle like this, and that's just to fit your straw through. So then make sure all the air is pushed out of your lung. We're going to put that inside there, put the plasticine on top, and then this one we want to seal really, really well. So again, we need to make sure there's no air gaps. So we want to seal it really carefully around the straw here, and also really carefully around the mouth of the bottle. Okay, and I think that's ready to go. So once you've got it all ready, it should look like this. Now when you breathe in, or before you breathe in, your diaphragm is up. And then as you breathe in, it pulls down, and then that's what inflates your lungs. That's part of what helps your lungs inflate. Push it up and it deflates, and pull it down and it inflates.
So you should be on your way to making your own model lungs. If you want to, you can obviously go back and watch the video of how I made it again, or have a look at the worksheet. It's got some more detailed instructions in there, so you can look at that if you're stuck as well. Now, if your bottle lungs aren't working, check on these three things. Firstly, is everything completely sealed? Check there is no air escaping from the sides of the balloon or through the top around the straw. If there is, put some more sellotape around the balloon at the bottom and just make sure your plasticine or blue tack is really tightly sealed around the straw. Then check that the straw is open. So if you crushed it closed with either the plasticine or the elastic band, then it won't work. And you can check that by blowing into it and making sure that the balloon inflates. And then check that the rubber band is tight enough around the balloon. Maybe try and secure it with some extra sellotape if you think it's not.